Hi guys, hopefully you're doing well, staying safe. Pray for everybody's safety. I'm gonna start the first video for lesson 3C for the summary. The exercises start here and we're observing vertex form. I assigned you questions here 1 to 3. Remember, if you're trying to identify the vertex, they already give you here the values of h and k, and when you remove the value outside of that bracket, this is reading as -4, but the actual point of the vertex would be 4, -5. This one over here for part B would be -7 and 1. So I'm going to do question 2 for you guys. So determine the equation in vertex form of this function. They plot these points. They give us the vertex at -1 and -8. And then they give us that point there at 2 and 7. So let's write an equation for it in vertex form. In vertex form, we want to write, the general form of this. So this is one of the first ones that we plotted together. The general equation for vertex form is y is equal to a x minus h squared plus k. So if we have the vertex, we're going to use this form because it's going to be helpful to us. We're given a point, so these are the values that we're going to be substituting for x and y. And since we substituted values for the vertex and this point, the only last value that we have to find here is a. So let's label what we have. So this is our h, this is our k, this is our x, this is our y, and this is what we have to find. So let's substitute. Our y is equal to 7, so we'll place 7 here. Our a we don't know. Our x is this 2. This is -h. This reads as negative here, so when I put it in here, I know it's going to be minus -1. So this is how we get plus. And then our k is going to read as -8. So let's simplify what we have to solve for a. So 7 is on this side. This is going to be 2 minus -1. So these two negatives will become positive. So this is going to become 3. And then if I square this 3, this is now going to be 9. So I'm going to have 9a. This is being subtracted by 8. We want to collect the like terms, so let's add 8 to both sides. So let's do that in a different color. Plus 8, plus 8. So here we have 9a is going to be equal to 15 is equal to 9a. And if we want to isolate for this, this is going to be a is equal to, divide both sides by 9. And then we're going to get 15 over 9. Now this fraction, we haven't had some in a while. This is both reducible. They both have values or factors of 3 in both of them. So if I divide 3 out of here and here, I would get an answer of 5 over 3. So now that I have our a value and we have our vertex, we can write our general form for the equation. We're going to write, therefore, the equation in vertex form is equal to y. I put our a value. I write our vertex at plus 1 squared minus 8. So if I plot this equation, it should give me a parabola that looks exactly like the one that they had in the question, and it should pass through those points that we plotted on Desmos and the one that they gave us. So let's take a look. So here's our graph that we're aiming for. Let's look here on Desmos. These are the points that I plotted already. So these are the points that were given to us with the vertex and the point 2 and 7. So if we write y is equal to 5 over 3, just move this over, bracket x plus 1. We're going to square this, and we're going to write minus 8. I can see that our parabola does go through this vertex that we indicated and that point at 2 and 7. So that's good. So I'm going to look at question 3 now. Here they have an equation in factored form, and they want us to write this equation in vertex form. So we want to get characteristics of this to get the vertex so that we can substitute it there in vertex form. So let's try that. So here they want us to write this expression in vertex form. So because it's in factored form, we can identify the x-intercepts. So we've kind of done the algebra for this before, but if I have it written like this, I can easily obtain the x-intercepts by making this equal to 0. And just by looking at it, I know that the first x-intercept is going to be equal to 2. So if you take it out of the bracket, it's the opposite sign. This one, the second x-intercept, if this is positive 6, when we take it out, it's going to be equal to negative 6. So this is good. We have our two x-intercepts, and if we want to find the vertex of this graph that's opening down, in terms of a sketch, if this is at 2, and this is at 6, I know that the vertex needs to lie in between those two values. So we would want to find the middle. So the formula for this, again, for the axis of symmetry is going to be x is equal to x1 plus x2. We're going to divide this by 2. So our axis of symmetry that will help us find the vertex, we're going to take our two x values that we found. Well, one's at negative 6, so my picture should have switched. Let's make this at 2. Let's make this at negative 6. And then over here, negative 6 plus 2 is going to be negative 4. Negative 4 divided by 2, this is going to give us negative 2, which would make sense that this would be equal to negative 2 here. So if this is the x-coordinate for the vertex, we want to find the corresponding y value. And so if I have an x value here, and I want to find a corresponding y value here, I would just substitute that value into that expression. So let's say sub x is equal to negative 2 into that purple expression. So let's write it in a different color. So we have y is equal to negative 2. This is going to read as negative 2 minus 2. So this gets substituted in here. Let's do it again. Negative 2 plus 6. So again, this expression I'm getting from the original up there. And let's simplify. So negative 2 minus 2, this will be negative 4. Negative 2 plus 6, this is going to be equal to positive 4. This is going to give us a value. These two negatives will become positive. This is positive 8 times 4 is going to be positive 32. So our coordinates for the vertex we have is negative 2 and 32. And again, if we want to write this in vertex form, our general form for vertex form is y is equal to a x minus h squared plus k. I don't have to worry about algebraically looking for the value of a when they gave it to me in the original, which is equal to negative 2. And I just have to substitute the vertex that we found. So our equation would read as y is equal to negative 2 x plus 2. So if it's negative there, it's positive here, just in the bracket. And this plus 32 will be there. So let's write both this expression that we found in vertex form, and of course we want to make sure that it's equivalent to the one here in factored form. So let's plot that on Desmos. So let me set it up for us. So I'm going to close these previous graphs. This one in vertex form was y is equal to -2. We have an x-intercept, we said, at +2, and one was at -6. So here's our graph. They give us to us in a purple color. So when we input our equation in vertex form, it should overlap it if it's the same one. So y is equal to -2 bracket x plus 2. We found as the axis of symmetry. And then we're going to subtract 32. Sorry, it's adding. So here you can see that my graph, it just overlaps. So if I remove this, you see that it's purple. If I click this again, it's black. We can do it in a different color as well so we can see. And make it orange. And then if I kind of do these dots, you can see that the graph overlaps. Purple, orange. Okay, good.